We have a compound A which is C3H6Cl2. This one on reaction with alkali can give two different products. One can be C3H6O and the second one C3H4. This is B and this is C. This B on vigorous oxidation, it is converted into a compound which is C3H6O2. Whereas the compound C on reaction with dilute sulfuric acid containing Hg2 plus ions, it gives compound D which is C3H6O. This one further reacts with bromine in presence of an alkali in order to give sodium salt of C2H4O2. And from this particular series of reactions, we need to find out what is this A exactly. So this is our A, C3H6Cl2. This one, when made to react with aqueous alkali, what is the product formed? Both the chlorines will be replaced by OH group, isn't it? So we get C3H6OH twice, which is an intermediate compound, and this is unstable. So it loses the water molecule, and that results in the formation of a carbonyl compound, and whose formula is C3H6O. So this is our compound B. So as this is a carbonyl compound, definitely this compound can be an aldehyde or it can be even a ketone. We need to check it out afterwards. Now the same compound A is made to react with alcoholic KOH. So why we are doing twice here? Because it's simply given that this compound is made to react with alkali. As there are two possibilities, we are using both aqueous KOH as well as alcoholic KOH. And this alcoholic KOH is meant for dehydrohalogenation, isn't it? So the product formed is an alkyne which is C3H4. And it is like this, CH3, C double bond CH. This is our compound C. This alkyne C is then made to react with dilute sulfuric acid in presence of Hg2 plus ions. Means it is reacting with water in presence of dilute sulfuric acid and Hg2 plus ions. We get an enol. This is a very common reaction in alkynes where the water molecule is added to alkyne. We get an enol. This one rearranges in order to get a carbonyl compound, isn't it? This hydrogen migrates to this particular carbon and this double bond comes in between these two. So we get CH3COCH3 and this is our compound D. From the data given in the numerical, it is very clear that compound B and D are different. When both are different and D is an ketone, definitely B should be an aldehyde only, isn't it? So what can be its formula? It is CH3CH2CHO. This is our compound B and this is our compound D. It's also given that this D react with bromine in presence of an alkali, giving rise to the sodium salt of C2H4O2, that is CH3COONA along with bromoform CHBr3. And this is another confirmation that our given compound D should possess methyl ketone group. So now tell me from the options, what can be our possible answers? Definitely we can avoid option A as well as option D, isn't it? Whenever both the chlorine atoms are attached to the same carbon, then only when made to react with aqueous alkali, we can get a carbonyl compound. So then there are two possibilities, either this one or this one. Suppose when we write the reaction for this one, that is CH3COH twice CH3, that is reaction with aqueous alkali, we get CH3COCH3, means even our compound B is CH3COCH3. So when both B as well as D are same, definitely this cannot be our answer, because it's very clearly given that B is different from D. There is only one alternative, so that one is option C. So here, when this is made to react with aqueous alkali, both the chlorines are replaced by OH group, and that intermediate compound is unstable, so it loses a water molecule, and finally we get this aldehyde. Is it clear now? Yes. So our answer is option C.